So the first question is, how small a change in climate is important? And the answer is a 1 degree centigrade, a little bit over 1 degree Fahrenheit, or a small shift in moisture-bearing winds. And the reason we understand this is that past civilizations have collapsed as a consequence of climate change. The Mesopotamian Empire, 4,200 years ago, which is particularly interesting because that's modern day Syria and Iraq, and had a lot to do with the underpinning for the Middle East War, plus many other civilizations, which I won't go through. Next big question, how fast can climate change and why does this matter? The bottom line is, we as scientists thought until about the early 1990s that climate changed very slowly, hundreds to thousands of years, which means that if you pumped tons of stuff like CO2 into the atmosphere, it would be a long, long time before it had an impact, therefore unimportant. Turns out that's not important. That's not true. The climate can change very quickly in what we call abrupt climate change. And between 2007 and 2012, in a matter of 5 years, the temperature of that very red area in the Arctic, the Russian Arctic, changed 8 degrees Fahrenheit. That's the equivalent of doubling the summer. So just imagine in Brooklyn, if the summer doubled, might be nice to some degree, but there are going to be a lot of things that go along with it for the entire state. The other thing that's quite remarkable about this abrupt climate change is that it is the same magnitude and speed as the change that occurred between the end of the last ice age and modern day climate 11,500 years ago. So we have recently experienced something very dramatic. Why did this recent climate change event occur? Well, for many different things come into play, but the thing that is in abrupt climate changes, which have happened in the past, but what we have done in the last few decades is absolutely unsurpassed, absolutely in the last 800,000 years, and we can go back much farther because the records go back 800,000 years. We have exceeded by more than 1.5 times the amount of CO2 in the atmosphere. And what's not mentioned so often is that that increase happened 100 times faster than it has in the last 800,000 years. So all of a sudden, we're in completely new territory. So how can climate change that fast? In basically faster than a political cycle. And just think about that for a second. That the climate system, which of course drives all of our weather, it's the underpinning for our weather, operating faster than a political cycle. It can do it in this particular case, which is our first abrupt climate change of the modern era, because of sea ice in the Arctic. Now, sea ice, when it exists, you see on the left side, that's 1980 September sea ice distribution in the Arctic. When there's a lot of sea ice, it's very white, reflects incoming radiation. When that sea ice is removed, and it doesn't take very much of a temperature increase because the sea ice is quite thin, 3 to 6 feet. What happens is you change the surface from white to dark ocean. The ocean absorbs that incoming radiation, but more importantly, the cap on that heat in the ocean is now released. So the net result is for 1 degree centigrade of rise in most parts of the world, you get in a place like the Russian Arctic, 3 to 4 degrees centigrade rise in temperature and a doubling in length of the summer. So how does that happen? How does it propagate throughout the Northern Hemisphere, this dramatic increase in temperature in the Arctic and loss of sea ice in the Arctic, when in fact, until then, we were really feeling relatively small changes. The warming in the sea ice basically changed atmospheric circulation patterns. And if you look to the left, you'll see a but a picture of the temperature distribution between the Arctic and the mid-latitudes prior to this event. Basically very cold in the Arctic, relatively warm in the mid-latitudes. That's a very steep temperature gradient, and therefore the jet stream, that reddish thing that you see there, becomes a very strong barrier, and it keeps the cold air up in the Arctic. All of a sudden, when you make the Arctic warmer, which we have done, the cold air can push farther south, the warm air can push farther north, because that barrier is no longer as strong. One quick example is in the middle of winter, around Christmas time at the North Pole, temperatures have on occasion been above freezing. Absolutely remarkable. The Greenland ice sheet, and now experiences warming over its entire surface. And I've spent months and years on the Greenland ice sheet. We never saw that before. This is particularly important because when you have cold air tongues shooting down and warm air tongues shooting northward, they come into contact, and as warm air comes together, you know exactly what happens. We get storms. So why does atmospheric circulation matter? Is because the air transports cold, heat, dry, warm, pollutants, and affects surface ocean currents. So if you begin to play around with the circulation patterns, allow cold air to go farther south, warm air to go farther north, you get storms, you get places becoming dry like California, which weren't before, you intensify forest fires, and it just goes on and on and on. You have an unstable climate. But because these tongues of cold air and warm air are very deep, they move very slowly. So we get stuck in patterns for a week or so, or 2 weeks. So next big question, how much have humans changed the chemistry of the atmosphere, and does that matter? We really only talked about the effect of CO2 so far. Well, the answer is we have increased CO2 levels. We produced acid rain, toxic metals like lead, mercury, cadmium, organic acids, in some cases, engineered chemicals, radioactivity. Believe it or not, even though the above ground bomb testing stopped in the 1970s, there's still radioactive material that moves around in some parts of the groundwater. And then, of course, particulates that we breathe in. We have created in the last couple of hundred years a chemistry of our atmosphere, the air that we breathe, that is unsurpassed in human history and probably unsurpassed in Earth history too. And of course, we evolve as a consequence of what we breathe and what we drink and eat. What are the health impacts? Well, you can read these: respiratory disease from small particles, neurological diseases, cancer from toxic metals, on and on. There are tremendous health impacts. So even if one doesn't care about the fact that CO2 is rising, which of course we should, there are still many things attached to it that impact our health significantly. So is legislation effective? There are two ways to deal with this problem. One, of course, is legislation, and the other one is starting with town meetings and town groups and things like this. So the answer is that we have experienced in the last 50 years a series of what I call environmental surprises that we actually caused, but they're surprises because we never thought that they would. As I mentioned already, Arctic sea ice, extreme events because air masses come together, moisture is no longer delivered to places like modern day Syria and Iraq, sea level rise, the atom bomb, and you can read the rest of them. How successful has legislation been? Well, anything that has a red star on it is a place where we actually have been fairly successful with legislation. The atomic bomb, there's no longer above ground testing. Antarctic and the Arctic ozone holes, based on the Montreal Protocol, that has been reduced dramatically, and the Antarctic ozone hole is healing. Why is that important? Because ozone, which is quite high up in the atmosphere, which if you compress it into a lid between your fingers would be about that thick, is exactly what protects us from incoming ultraviolet radiation. So I would contend that climate change, and I'm certainly not the first to say this, is the greatest security issue of the 21st century. It impacts our health, our resources, our economy, ends up providing catastrophes for us, and has big geopolitical implications. So what's the good part of this story? The good part of this story is the last two PowerPoints. These are brief examples of what mitigation could accomplish, and you'll hear a lot more from the next two speakers, no doubt, about the things that will get better as we begin to pay more attention. Health and resource depletion, cleaner air and water. 7 million people a year die prematurely from bad air quality. A year, 5 million people died from COVID. An increase in human and ecosystem health in general would occur. And we know this from COVID and from 9/11, when we shut down a lot of things. The economy, more efficient use of our financial resources, and reduced dependence, obviously, on fossil fuels. Catastrophes. If we were able to mitigate the greenhouse gas effect and all of the pollutants that go along with it, and these pollutants can come out of the air in a matter of days. Obviously, you can't shut everything down, but some of this can be done very fast. We would reduce food insecurity, and also migration of humans and ecosystems. And in the case of geopolitics, the fact that we have an entire new ocean, the Arctic Ocean, that many countries are now debating where they have rights and where they don't have rights would not be a problem. So what's Maine's potential? We're in a great situation. That doesn't mean that we're not being impacted. We have Lyme tick, but we do have natural resources. We have water, of course, which is very important. And all of the predictions suggest that we will have even more water in the future, except there will be times, as there have been in the past, where we'll have drought. And those, because the climate is now so unstable, if we had 2 years in a row of drought, all of a sudden we would be like Nova Scotia and Quebec. Forests, we're super fortunate to have forests for a whole variety of reasons for the economy, but also forests take up about 75% of all of the carbon that we emit. We're a small population, so we're almost carbon neutral because of those forests. If we were to mitigate, we would obviously have reduced pollution, and much of the pollution does not come from Maine. It comes from surrounding areas. Wind and solar power, no matter what the debate is about the pros and cons, having wind and solar power as renewable energy makes plenty of sense. We would have energy independence. Offshore wind power has its issues, but the bottom line is that we would basically be the Saudi Arabia of the northeastern United States. We are the equivalent of an Eastern Alaska because we're the gateway to the Arctic as people begin to transport materials across. It would help organic farming from having our own power sources. We have water and we have a lot of land. It would improve the economy and provide more jobs. It would increase the population, which a lot of people may not be happy about, but it could very well be a reality. I personally believe that we'll see a doubling of Maine's population in the next couple of decades. And overall, if you add these things up, it increases our quality of life. So if you're interested in seeing some of the data, the results from our Institute software, you can go to what's called climatereanalyzer.org. And that gives you not only today's weather, projections for future weather, but also allows you to see how different things are anywhere on the planet in any type of climate. And we also have a publicly available app called 10 Green that provides you with air quality information. Anybody wants more information about any of these things, or wants help working through it, I'd be happy to help you. Thank you.